Hi everyone, this is Julia from the Macedon Public Library. It's Wednesday, and that means it's our time for science talk. So I have here again Brian, my husband, who is going to talk about solar eclipses, which we both experienced together in 2017. We went to Southern Illinois, and then last year he went to Chile, so he experienced it in the Southern Hemisphere, shorter. No, about the, I don't know. Anyway, I'll get out of the way and let him talk. Here he is.
Hi, everybody. Welcome to my weekly talk about science. So yeah, I thought I would talk about solar eclipses, which are different from lunar eclipses, and feel free to jump in with questions at any point. The basic idea is an eclipse, a solar eclipse, happens when the moon passes in front of the sun. And you can have a partial eclipse where the moon, its orbit is not quite lined up with the sun, so it will only cover part of the sun. And then you can have a total eclipse and something called an annular eclipse. So the reason you can get a total eclipse is that the moon is about 1/60th the size of the sun, but the sun happens to be about 60 times farther away from the Earth than the moon. So when you look in the sky, they have about the same apparent size. It's really close. And so when it lines up in just the right way, you can have the sun exactly blot out, the moon exactly blot out the sun. Now, that's when you have a total eclipse. The moon and the sun have to line up perfectly, and the position of the moon in its orbit has to be such that it blocks the sun. What an annular eclipse is when the sun and moon are lined up properly, but the moon's orbit isn't quite circular. So when the moon is farther out from the Earth than it typically is, it's on what they call apogee. When it's farther out, it's a little bit smaller than the sun. And so what you get is a ring of the sun that isn't covered, and that's a little bit different. So if you saw the eclipse in the United States in 2015, that was a total solar eclipse for a specific path. 2017. I get the dates up. There is another one that's going across the United States in 2024. In April 8th, 2024, there'll be another one. And if you are in the Rochester area, this particular path of the total solar eclipse will go over Rochester, it'll go over Macedon. So if you're at the Macedon Public Library on April 8th, you can see a total eclipse, assuming that we don't have clouds. And given that it's April,
Or snow.
You know, we might have snow. Who knows? So that's kind of the basic idea. One of the things that's kind of a misconception is that eclipses are very rare. It turns out that eclipses typically happen about twice a year. So you get basically 2 solar eclipses and 2 lunar eclipses. That's when the Earth passes between the sun and the moon. You get about 2 of them a year. The reason we don't see them often is that unlike a lunar eclipse, when the Earth passes in front of the sun, all of the moon is going dark, and if the moon's up, you can see it. So lots of people see lunar eclipses. For a solar eclipse, you have to be exactly in alignment, and not just on the Earth. You have to be in the right spot on the Earth, because the moon is smaller than the sun. The only path that you get is along that direct straight line between the sun and the moon that pass a narrow little spot along the Earth. And so if you're outside of what they call the path of totality, that area, which is probably about 40 miles wide, if you're outside of that, you're not going to see a total eclipse. You're going to see a partial eclipse. And even if you're really close to the path, you still won't see a total eclipse. The moon will cover most of the sun, and then it'll go away. And so every now and then we'll have a partial eclipse that happens to be in your area. but a total solar eclipse, you have to be exactly in the right spot. And so even though they happen twice a year, they don't happen anywhere near where we live, and so we don't see them. Mostly over water, mostly, equally in the southern and northern hemisphere, so, it could be all over the place. But if you have a total solar eclipse in Antarctica, for example, that's not very helpful if you live in New York. So you have to have just the right alignment. And in fact, the 2017 solar eclipse was only a partial eclipse in New York. There was no part of New York that had the total solar eclipse, which is why we drove to Illinois, because half of the eclipse passed through Illinois. But the 2024 one in April, assuming we have clear skies, will be a total solar eclipse in New York, in Macedon, so you won't have to drive anywhere. Julia asked how long it will last. I want to say a few minutes.
I think it's going to be longer than
It'll be, well, it depends, because it also depends on where you are. Where you are along the path, the time is a little bit different. But a few minutes. It's not a particularly long solar eclipse, but it's not a short one either. So that's kind of the basic idea.
the difference between
So Julia's asking me questions.
Sorry.
Since nobody else is asking me questions, Julia's answering me questions. And what she asked was, what's the difference between seeing it as a total solar eclipse and a partial solar eclipse? Partial solar eclipse, you get the moon covering part of the sun. If it only covers a little bit of the sun, you might not even notice it. The sky will get a little bit darker, but it's not a big change. If it covers a lot of the sun, so a good portion of the sun, then you do get some weird effects. One of the things is the sky will kind of look odd, because as the moon passes in front of the sun, what you don't get is you don't get a disk of the sunlight, you get only a crescent of the sunlight. And because you get the crescent of the sunlight, the shadows go blurry. There's this effect of light where the shape of your light source affects how the shadows are going. And normally we wouldn't notice that because the sun is circular, and so we have all of the shadows have nice sharp edges. But during a partial eclipse, the shadows from things will go fuzzy, because they'll all have that kind of crescent shape. And in fact, if you look through leaves, for example, where there are gaps, where little spots of sunlight on the ground or something, you can see little crescent shapes because of the partial eclipse. And the sky will go darker, it'll kind of go grayish, and then once it's reached as much as it's going to go, it'll start to get brighter again, and that's about it. So it's an interesting thing to see a partial eclipse, but it's not the same as a total eclipse. So a total eclipse, what's really different is you get the same partial eclipse up as it's approaching totality, that period in which the moon completely blocks the sun. So you get the same weird shadows, you get the same kind of fuzzy gray sky, but when the moon completely passes in front of the sun, you get some very different things. One that you get is when it passes completely in front of the sun, the sky literally goes dark. I mean, it really goes dark. And if you know, you can look out at the sky, you can actually see stars and planets and things like that. And that happens within maybe 10 or 15 seconds. It goes from kind of dimmish gray to dark. If you can see the horizon pretty well, you'll see where the sunlight still exists on the horizon, what's called a ring of fire there. You can see this kind of twilight glow in all directions. So it looks like twilight or sunset on all of the horizons in all directions, because that's where there's still light. The other thing is that during totality, during the total solar eclipse, and only during totality, you can look at the sun without any special glasses. And what you will see is this dark region where the moon is, and then you will see the corona, not the virus, but you'll see this corona of the atmosphere of the sun glowing around the moon. and it's this weird pinkish white color because it's extremely hot gas, and so you will see that. You will also feel the temperature drop. Birds and insects will think it's night, and so they'll go to sleep, or wake up, depending on what they are, nocturnal or not. And so you get all these kind of weird effects, and that's a very different thing. So if you get a chance to see a total solar eclipse, you should definitely do that. It's very different from partial eclipse. And it's still kind of a hard thing to explain until you kind of experience it. And one of the things that happens is that sometimes people will experience it, and then they have to travel all over the world to try and experience more of them. So there are actually people who travel all over the world to see total eclipses. And when it comes to Macedon, there will be people who travel from other parts of the country and Canada and stuff to come to Macedon to see an eclipse, assuming the weather is going to be decent. So hotels will be packed. If you have an Airbnb, make sure you block that period out so you can charge extra, because people will come. So it's a big phenomenon. When we went in Illinois, the eclipse, when it happened, it was fairly close to where my parents' farm was, but traffic coming in and out was a nightmare. So you could see everybody was driving into the path of totality, and everybody drove out of the path of totality afterwards. So it's really quite a thing, and we're going to see that here in 2024. People will come up from the southern part of New York and other southern states, and they'll come down from Canada, and they'll want to come into these areas and see all of this. So it's going to get crowded. So Joey wanted to know if you guys have experienced the partial eclipse in 2017. Did you see any of that? I'm sorry?
I said, I think I remember it. It didn't get really, really dark, but.
No, it wouldn't have gotten really, really dark. You just kind of saw maybe funky shadows, or if you had some solar glasses, you could see the crescent shape. So.
No, I didn't notice any shadows or anything. I just noticed that the light was dim.
Yeah. Sometimes if the moon doesn't cover too much of the sun, you don't necessarily notice the shadows unless you know what to look for. Mm-hmm. One of the things you can do is actually make what they call a pinhole camera, or just take a piece of paper with a small hole in it. And if you do that during a partial eclipse, you can actually see the crescent shape, because the sunlight has to go through this small opening, and then it shows you what the shape is. Mm-hmm. So that's kind of a fun thing. Sorry. So Julia keeps asking questions. She wants to know how it was different when I went to Chile. So the real big difference is when we went in 2017, it was in Illinois, and it was basically at sea level. I mean, it was in just kind of the same way as New York. It was, in standard sea level, in moderately clear skies. And so you could see some of the horizon because it's a fairly flat area. But when I was in 2019, when I went to see the eclipse in Chile, I was actually at an observatory. So we were at about 8,000 feet. So it's really high up on this very mountainous area in the foothills of the Andes. And so you could actually see the shadow coming in, because you could see for miles and miles and miles, the shadow was actually coming in. So you could see when the eclipse was coming before it happened, because the shadow of the moon was passing across the ground. And so you could see that. The other thing is that you could really see the ring of fire, because you could see enough of the horizon. You could actually see where the moon's shadow was, and then see past that to see like distant hills that were actually still in sunlight, which was pretty wild. And that was a big thing. So, and it was perfectly clear skies, because it was out in the middle of the desert. So it was very different than it was in 2017. So, And I met eclipse chasers, so I got to meet people who actually travel all over the place to see this. And traffic was a nightmare because Chile has one road that goes north and south. There was only one highway they call Ruta Cinco, which is Route 5, that goes out of the town where everything is up to the observatories. So driving back after the eclipse, I was actually in traffic for about 7 hours to go 20 miles.
Wow.
So it was really a madhouse. The one advantage is that because I work for NRAO, when they rent you a vehicle, they rent these big American-sized diesel trucks that can actually go out onto dirt roads and everything. They're certified for the mining area. And the thing is, in Chile, most people have little smart car Fiat-sized things. So their buses are smaller than an American truck, basically. So I had this huge vehicle and a whole bunch of other little vehicles. So when I needed to change lanes or anything, they moved. They hated me, I'm sure. I'm the ugly American who's going, I need to get in the other lane. Fortunately, I don't know Spanish swear words, so I don't know how they're yelling at me. But it was quite a thing. The real challenge was in the town where I was. They have very narrow roads, so it's kind of interesting to try and drive a truck down some of these narrow roads. Some of them are 2-lane roads, but when I went down, it was a 1-lane road. They were going to get out of my way. So
Wow.
it was an adventure. I'm glad I did it, but I can't imagine doing it again.
Wow.
Yeah, it was quite a thing. Yeah, Joey has another question.
What about other planets with their moons? Do they have solar? Like
So
Mars or whatever,
Julia asked if do other planets have eclipses? And in terms of a total solar eclipse, the answer is no.
We're lucky.
We are the only planet that has a total solar eclipse. And the position of the Earth and Moon are such that probably if there were aliens that could visit Earth, they would come to visit for a total solar eclipse, because it's probably even rare in other solar systems. There are moons that pass in front of the sun on other planets. They don't completely cover the sun. Because
Didn't I see a picture where Venus or Mercury passed across the sun?
those are called transits.
Yeah.
So Mercury has passed in front of the sun several times. Venus has. Venus is probably most famous because it's easier to see than Mercury. Mercury is a small planet and it's closer to the sun, so it's really tiny. You kind of have to have a special telescope to really see it.
Oh.
But Venus you can see with the naked eye. It's not the easiest thing, but you certainly can see it with the naked eye. The Venus transits. And the Venus transit is probably most famous because it was used to figure out how big our solar system was. So basically, when you do astronomy, you can do measurements against the stars to see, well, Venus's orbit is about 70% of Earth's orbit. So Venus is about 70% the distance of Earth distance. And you can say, well, Mars is about 1.5 times the distance of Earth. Jupiter is about 5.2 times the distance of Earth, and so forth. But because of the way you look at the stars, the only way you can do is geometry. So you can find relative distance. So even way back, hundreds and hundreds of years ago, we knew what the basic orbits of all the planets were in size relative to all the other ones. But we didn't know how far away the sun was from the Earth. And so when you have a transit of Venus, what you can do is, because Venus is in front of, or in between the Earth and the sun, when it hits the edge of the sun and when it leaves the edge of the sun depends upon where you are on Earth. So you can have different astronomers that look at a transit of Venus from different points on Earth, and you can do the math to figure out how far away Earth actually is, because you know that how far the distance is on Earth, and then you can use that to figure out how far the distance is from the sun. So back in the 1700s, when they finally were able to do this and actually take timed measurements of Venus crossing the sun, I want to say 1742, but I'm probably wrong there. When astronomers did that, it was the first time when we really had an accurate measurement for the size of the solar system. And once you had that, you had the accurate distances to all the planets. So the solar eclipses were actually calculated. They were one of the first things that are actually calculated in astronomy. And so even going back, I want to say at least 3,000 years, there were astronomers that were able to predict when and where a solar eclipse would be with some reasonable accuracy. Back then, they didn't know, exactly how everything was orbiting, but they could look at patterns and motions and figure them out. So we've known about solar eclipses for quite some time. In fact, there was was it a 1785 book that calculated the one I went to in Chile in 2019 is actually first calculated in, I think, a 1785 book. It calculates them all the way out to 2100 or something. So I can actually go back and find the book and go, yep, there's the path. And so they actually had, accurate ways of calculating this out. So, and it's funny because it went right across a town called La Serena, and La Serena didn't exist at the time that it was predicted. So
That's amazing.
So yeah, it's quite a thing. It used to be big
Amazing.
in astronomy, but now it's like just a tourist thing.
So do you have any big plans for 2024?
I plan on not traveling and seeing one locally. I dealt with a 10-hour drive to go back to Illinois or 12-hour drive to go back to Illinois and all of that traffic. And I dealt with Chilean traffic. I am very much looking forward to not traveling, not going anywhere. I want to have a sunny day, kick back and grab a glass of scotch and sit in my backyard and go, yep, that's an eclipse.
It's happening in April, you said?
April 8th, 2024.
Oh, okay.
So
Cool. How can they predict it?
Timing the
and then
measurement.
that will be the last solar eclipse for 80 years in the United States. Within our path, it's not going to happen for a century after that.
Oh, well, we better catch this one.
Yeah, you got to catch this one. This is the one to catch. Otherwise, you got to travel.
Yeah. Nope.
Yeah, like I said, you can catch one about every couple of years, but no. So Joey asked what the difference in temperature was. I want to say when the one in Illinois, I think it was, I want to say it was about 10 degrees. When it was, the one in Chile was a good 30 or 40 degree drop.
Wow.
Because it's very dry and it went from full sun to cold. And one of the interesting things is it hits and you feel the temperature drop. And then the sun comes back and the temperature's still dropping because all that heat has been taken out of the atmosphere, and it just takes a long time for the temperature to actually drop.
Huh.
So you're back in sunlight and it's freezing.
Oh my.
So
Interesting.
Yeah, you'd expect it to warm right up.
yeah,
Huh.
so in April it could be cold.
Yeah.
And here you could get, what probably will happen is it'll be enough moisture in the atmosphere that even if we have kind of a clear day, after the eclipse goes by, you'll get clouds, and then you could get some rain or snow even.
No.
Because again, the temperature drop causes the moisture to condense in the air, so you often get cloudy skies afterwards.
Mm-hmm.
So, and in fact, in 2017, you could see the weather maps,
Yeah.
and you would see the path of the moon's shadow, and then you would see all these little pop-up storms appearing after it.
Hmm.
Yeah.
I never gave that a thought.
Yeah.
Yep.
Oh, it's a hot day.
Because it was kind of a hot day, and then it dropped, and then you get this kind of cool, foggy, rainy day afterwards. So yeah, it's an interesting thing. It affects animal navigation. It affects temperature. It affects not just human behavior, but everything else.
Things I never gave a thought to.
Yep.
Yeah, and I'm sure the library will be doing something.
Thank you.
I hear
Probably.
Julia laughing, but I bet the library will be also doing something.
Yes.
Yeah. The only way I'm not at the library is if I actually get called by my job or I have to be somewhere else. But I don't think that's going to happen.
Probably. I would guess the library. Like, so the people are prepared.
Yep. So the library will probably do something at a time. They'll probably do a whole bunch of things because it's quite a deal. But yeah,
Great.
it's kind of the big thing.
Yep.
It is.
So, any other questions or anything? Or
I don't think so.
No, just appreciate your
interesting.
doing this
Yeah, we appreciate it.
presentation. Very
Yeah,
interesting.
we like your presentation.
well, if do you have any other ideas for science topics you'd like to see covered or like me to talk about? Because if I can fill one of Julia's thing every week, then that's good for her. So,
Okay.
That'd be great. Well,
Yeah.
almost anything science, because science
Yeah.
is not my strong suit.
But we like
Okay.
to.
But anything
about
scientific, I love. I will learn. So that's
Okay.
good.
okay.
Okay.
Thank you for coming, and if you think of any other questions, you can always contact Julia or Stacy, and I'm sure we're happy to forward it along. So
Okay,
Okay.
thank you, Brian.
Thank you, Brian.
okay, thank you. I click in meeting. Okay, I'm clicking in meeting now. Bye. Thank you.
Bye.
Thank you.